This is Current Thought, Con Edison's podcast providing a first look at the cutting-edge ideas, innovations, and technology that is capturing the attention of the energy industry. Today's guest will have you thinking about energy in a whole new way. It might just change your life.
Welcome to Current Thought. I'm your host, Anne-Marie Corbliss. On today's show, we're talking with Con Edison's Greg Koumoullos, a project manager for thermal energy networks, a research and development project that takes waste heat recovery to a whole new and exciting level. Welcome, Greg.
Hey, Anne-Marie. How are you doing today?
Good, thanks. We've heard a lot about thermal energy networks, and I know New York State has some really ambitious climate goals, and we have a lot of buildings in our service territory that use fossil fuels for heating and hot water. Switching buildings to low carbon energy sources is just one of our goals. And one of the potential ways to do that is by creating thermal energy networks. Can you tell us what a thermal energy network is?
Yeah, a thermal energy network, it's a series of pipes owned by Con Edison that carry water to transfer heat between different thermal resources and different buildings. The buildings then connect their heat pumps to our system to harness that energy and provide a fossil fuel-free energy solution to their buildings for heating and cooling.
Why is Con Edison interested in thermal energy networks?
The purpose of them, right, is to look to try to find an efficient way to decarbonize buildings and eliminate the on-site greenhouse gas emissions from fossil fuels. That's the point behind them. And why we're interested in them and how we came about this really all came from last summer. New York State passed a law called the Utility Thermal Energy Network and Jobs Act. And with that law that was passed, it required a couple of things. One of those was for the New York State Public Service Commission to require the 7 largest utilities in the state to develop these pilot projects for these thermal energy networks. And then also it required the Public Service Commission to propose some rules and regulations for how a utility could potentially exist as a thermal service. So that's kind of what got us into the space right now. And really part of the law also tried to help us understand the whole job transition of the workforce of the traditional gas system workers over to potentially a thermal energy network. As we start to decarbonize and reduce fossil fuel usage, there could be also a reduction of the workforce related with that fossil fuel usage, such as the natural gas workers.
Thermal energy networks, is that a new idea or has it been around for a while?
So the technology around the use of heat pumps and geothermal is not really new at all. I mean, geothermal heat pumps have been in use here in the U.S. and overseas for well over 50 years now. And the idea of district geothermal systems, it really has been in Canada now for the last 10 or 15 years, mostly in the new construction, new development side of the industry, where new buildings are connecting these systems because of their great high efficiency. What is new is utilities, especially here in the States, owning and operating these systems for buildings that are fully retrofitted, existing buildings that we're looking to come off of fossil fuels and get onto these systems. That part is new. And really, New York State's really at the forefront here. There is one state, Massachusetts, currently has one pilot project, very similar to our Mount Vernon project. There's about 13 other states that are slightly behind New York now, also starting to look into these type of pilot projects. So, we're excited to be at the forefront, and we're hoping we can leverage the knowledge gained from, over 50 plus years of this technology into a system that really works well here for Con Ed and our customers.
You mentioned pilot projects. What are they?
Yep. So Con Edison actually has proposed 3 unique pilot projects, which are going to test a variety of different building types, different types of thermal resources, such as boreholes and waste heat, as well as trying to develop different thermal rates for our customers and eventually completely different designs to test out these different thermal energy network systems.
How does a thermal energy system work, Greg?
When we talk about thermal systems, we're basically transferring energy, heat energy, from one point to the other. So connecting, how these whole systems work is, imagine a series of pipes with a fluid inside of them. Typically, that fluid is going to be a water-based system. And we're going to be connecting these pipes filled with water to different buildings and also connecting them to different thermal resources. So a thermal resource can be something like a bore field, which pretty much uses the constant temperature of the ground, the earth, as kind of battery storage to either take heat from away or add heat to. And then those pipes and systems will be connected to buildings, and those buildings would install heat pump. And you maybe have heard heat pumps, kind of like a typical heat pump you hear about are air source heat pumps or the ductless split unit air conditioners that can provide cooling and heating. Those rely on the outside temperatures, and they try to pull heat from those outside temperatures in the wintertime and then also try to push heat onto them in the summertime. In this case, we're going to be connecting those heat pumps to a geothermal system or a thermal energy network, which has a steady temperature somewhere in the 30 to 70 degrees range. So by trying to pull heat, instead of trying to pull heat out of cold temperatures in the wintertime that are outside, you're only pulling heat out of maybe a 50-degree temperature water, which is much more efficient. Same in the summertime, instead of trying to push heat into a hot summer day outside, you're pushing the heat back into a pretty steady 50, 60-degree temperature system, which allows those heat pumps to work extremely more efficiently and be a really great solution to reduce the greenhouse gas emissions.
So the difference between a thermal energy network and a home that's geothermal would be the size of it. Am I right? Or is it something else?
So typically a geothermal installation would be installed for a single-use customer. So there's a couple companies out there today that you can take your existing natural gas boiler and replace it, hire a company to come in. They'll install 1 or 2 boreholes in your yard and install a ground source heat pump as a solution. Imagine for a thermal network would have multiple buildings connected to maybe one set of borehole fields, where you could have, not every customer would have to have their own boreholes, and you can connect multiple buildings and you can transfer that heat energy amongst different use cases. So it could be a commercial building, which is cooling when the other, maybe a residential building is heating, and they can be transferring heat and sharing heat amongst the different types of customers. Having multiple buildings, multiple customers turns it into a network. And then having it owned by utility turns it into a utility thermal energy network, or what we now call a U10, utility thermal energy network.
That sounds way more efficient and cost effective than just building by building. So what kind of buildings or neighborhoods would work well for this kind of technology, Greg?
Yeah, great question. And really, in our pilot project, we're testing a wide variety of buildings, everything from single family home in Westchester to a 70-plus story skyscraper in Midtown Manhattan. We're really trying to find the full spectrum of our customer base to make sure that these type of systems could work with everybody. So what we've developed here for our project are 3 unique pilot projects. The first pilot project is in the city of Mount Vernon, which is in Westchester County. And in that one, you have a community of about 75 different buildings, ranging from single-family homes to 2, 3-family homes. Included also are some low-income housing units. We have 6 different churches, a firehouse, a rec center, medical offices, all tied together using 3 large bore fields. So just like we talked about in the home, we have maybe 1 or 2 boreholes that go down 500 feet down to really capture the stable temperature of the earth. Here, we're going to have 3 large bore fields totaling of well over 100 boreholes total, and they'll be sharing energy amongst that community. Another pilot we have, which is in Chelsea, part of Lower Manhattan, that's actually connecting a data center, which is a commercial building that is constantly cooling because of all the computers in the data center, and tying that into a New York City Housing Authority buildings, residential buildings, low-income buildings, and they range about 7, 8 stories for heating and cooling solutions, and we have a larger tower for domestic hot water use, where they'll be tying into our U10 system. And then finally, our other project is Rockefeller Center. So right in the middle of Midtown Manhattan, where we have Rockefeller Center, the campus, which has tremendous amounts of extra waste heat from all of the cooling they're doing to their buildings, and also recovering heat from their existing steam system and their steam condensate. We're going to tie that into our network, and we're going to transfer that to 3 large buildings, one of them over 70 stories tall, where they'll be using our network and very large heat pumps to produce heating for their building. So the spectrum is tremendous for what we're trying to do.
Where are we in this process, and how do we measure success for these projects?
So right now, we're in a good place. We submitted our final proposals to the New York State Public Service Commission, and we're awaiting feedback from staff of the commission to approve us to go into the next stage of the project, which is the full designing of these projects. And once we get the approval for that full designing, we'll be designing these projects out for pretty much most of 2024, and then submitting for full approval of construction by the end of next year.
What does success look like for this technology?
Yeah, for us, so success is us really learning of what these are. So obviously, we're going to have to design them, and we're going to have to build them. And while we design them and build them and operate them, we really want to learn. And we want to learn a couple key focus areas. We want to learn on the actual engineering of a thermal network, because that's something that is somewhat novel to us in the U.S. and the state and the utility here at Con Ed. We want to learn about the economics involved in this, as well as how to operate these systems. And then in addition to that, we really want to get a good understanding of what that labor transition looks like. We have a very experienced gas industry workforce that works for Con Edison. We want to take a look at how we can leverage the experience that we do have with a lot of the similarities between our gas system and these thermal energy network systems, which pretty much use a lot of the same piping and type of infrastructure. And at the end of the day, we really want to have another tool in our toolbox for reducing carbon emissions and meeting the state's very aggressive climate goals. And we think that thermal energy networks could potentially be a nice tool to have in that toolbox.
So if you looked into your crystal ball, when do you think this technology would be ready for the average customer to use?
So taking us back to our timeline now, we're hoping to start construction of these projects by 2025. And we're going to run these projects as pilots for at least 5 years. Now, throughout that time, we're going to be learning and gathering a lot of information. And the New York State Public Service Commission is going to make some determinations of where they think these type of thermal networks belong in the regulated utility space. Once we're into 2030 and we ran our 5 years of our pilots, we'll have a better understanding of where these will sit and where more of our customer base will be able to take advantage of these thermal energy networks.
Why are we doing this? Is this part of the clean energy commitment?
Yeah, look, we're very, very excited about these projects because of the potential that these projects could bring. So reducing greenhouse gas emissions and meeting the state's aggressive climate goals are going to be extremely challenging, and it's going to require a multifaceted approach. So we're hopeful that these thermal energy network systems could be part of that solution. And the only way we're going to learn that and know if it is by having these pilot projects and operating them and really gathering all the learning to see where these tools can fit into our toolbox of achieving these climate goals. Think of everything that generates heat in our house and our worlds. If we, instead of wasting that heat down the sewers or wasting the heat outside to the environment, if we can reharness that heat and reuse it and have an efficient system like a thermal energy network or like ground source heat pumps to kind of capture that heat, we're really being as efficient as possible because we're reusing the energy that we've already created. And that's really the beauty of these systems and the heart of why this becomes a very compelling solution to our climate goals. And we're looking at potential for the future to tap into other great resources like sewer heat recovery. All of our sewer systems, the water in our sewer systems is typically relatively warm, 60, 70 degrees Fahrenheit. And we could tap into that resource, the great ability to kind of take that thermal energy and put it back into our systems and allow them to operate in our very efficient heat pump systems.
Is there anything that I didn't ask you that you'd like to tell us?
Yeah, what I want to do is talk a little about, where you can find out more information about this thermal energy network. So, we've just recently put up a great website. If you go to coned.com/thermal energy, and you can get all the information about our current proposals and what our plans are, and also a little bit of some diagrams explaining kind of how these networks work. It's a really great resource that we're hoping to get and share information and, welcoming as many questions as possible. As a big part of starting kind of a new utility here in thermal networks is sharing that knowledge. And it's very important to us that all of our customers and stakeholders really have a good understanding of what these networks are, what the technology is, and how we plan on testing these out in these pilot projects.
Greg, thanks so much for being our guest today on Current Thought. We look forward to hearing more about the project and its potential in the future.
Thank you so much for having me. It's been a great discussion and looking forward to talking about these in the future.
If you want to know more about Con Edison's research and development of waste heat recovery, check out our October 18th podcast with Sylvia Curran on YouTube. And that's our show. Thanks for listening.
If you have a technology, an idea, a comment, or a question, send us an email to podcast@coned.com. We'd love to hear from you. Remember to follow us on all our social platforms: Twitter, Facebook, Instagram, LinkedIn, and YouTube. Our handle is @ConEdison. Make sure to use our hashtag #CurrentThought.